This is a demonstration of Lab 3.1, separating soluble and insoluble solutions. Now, last week we looked at a few different mixtures, including some liquid solutions. However, today we're going to be looking at some techniques that can be used to separate these solutions back into pure substances. The materials I'm using today are a couple of graduated cylinders, some beakers, a cup, some spoons for stirring, and then some smaller scoops for measuring things out. I have some funnels, several sheets of filter paper. If you're at home, you can just use some regular paper cut into circles, and a few test tubes. One common technique that scientists use when separating mixtures is filtration. We're going to be using a filter paper today to filter both of our solutions. Now, this is like a thick, heavier weight actual filter paper, but in a pinch, most kind of papers can be used for this, so long as you follow this specific folding technique. Start with a round circle of paper and fold it in half. Then fold it in half again. At this point, you should have a kind of triangular crescent shape. If you pick it up, you can see all four sides of the fold. Go to that 1, 2, 3 furthest kind of gap and open it. You should have something that is a conical kind of funnel shape at this point, and you can actually fit that into the funnel. Now, the general idea with these filter papers is that with them fit into the funnel, we can pour any kind of mixture or solution we want into the top, and the paper will block any solid particles from passing through. Obviously, water is going to be able to pass through this thin piece of paper, even if it's a bit slowly. And so any solid particles will get stuck in the paper, and any liquid will pass through to the bottom of the test tube. At this point, if you have not done so already, pause the video and record the procedures and materials that have been shown to you so far. The first solution that we're going to try filtering is this copper 2 sulfate solution. It is a mixture of the chemical copper 2 sulfate and water. Some of you may remember heating up the copper 2 sulfate. It was the larger blue crystals that we placed over the flame just before spring break. At this point, I want you to pause this video, write down any observations of this solution that you have, and predict what do you think will happen when I pour this solution through the filter. All right, I'm going to carefully take this bottle and pour it slowly. I'm going to pour just a little bit at a time. You can see that it takes a little bit of time even for the liquid to pass through, but it is dripping down. Right now, it appears that the liquid passing through still has a blue color, which tells me that this is not the pure substance water. Do you think that some of it has been filtered out? It looks a bit lighter, but that could be just because there's less of it in the test tube so far. I'm curious to see if once it's all passed through, if we'll see any solid particles in the top. So let's give this just a moment. All right, it looks like this filter paper has just about stopped dripping. We can see this is everything that was able to pass through into the test tube. If we look up into the filter paper, it looks wet. It's a little bit stained blue, but I don't really see much left behind. Go ahead and pause the video and write down these observations. What do you think that means for our success in filtering and separating this mixture? This zinc oxide and water. We have also dealt with the zinc oxide before. We heated it up and it stayed very powdery and yellow. We also looked at it last week. This is the super powdery white substance. I'm gonna mix like 2 scoops of this with water, and then we'll pour it into the filter paper just the same. All right, this is what our solution looks like after I've stirred it up with the spoon. I just remembered you guys also created this solution in a lab yourselves where you shook it up in a test tube. Yeah. After observing what the solution looks like, kind of cloudy, milky white, I want you to go ahead and write down your predictions. Do you think that anything will be left behind in the filter? Do you think we'll be able to separate this substance? Yes or no? All right, here we go. This one's leaning a little bit. I hope I don't spill it. All right, I see this one starting to drip, and we'll wait a bit longer to get some conclusive results, but the liquid that's coming through initially looks pretty clear. It looks a lot like water to me. All right, so it looks like our zinc oxide solution is finished filtering, and my initial observation was correct. Even now that this test tube's full, it looks totally clear. I probably wouldn't drink it, but it looks a lot like water. And if we look up here in the filter paper, I can already tell that something funky's going on in there. It looks like, even though this filter paper's wet, that there's kind of like a white powdery residue everywhere, or even quite a bit of white stuff piled up there in the bottom. We have been able to separate our solution back into its 2 components, water and zinc oxide. However, we still have an issue over here with the copper sulfate solution. At this point, you can go ahead and stop the video and answer any questions that remain in the lab. In our next lab, we're going to look at some additional separation techniques that can help us maybe with this kind of solution over here.